In this video, we'll be focusing on the superposition theorem, which is used in various aspects of electrical engineering. By definition, the superposition theorem states that for a linear system, the response, which is the voltage of the current, in any branch of a bilateral linear circuit having more than one independent source equals the algebraic sum of the responses caused by each independent source acting alone, where all other sources are replaced by their internal impedances. When changing sources, all independent voltage sources are replaced by a short circuit, which eliminates all differences in the potential, as the internal impedance of an ideal voltage source is zero. All independent current sources are replaced with an open circuit, which eliminates current, as the impedance of an ideal current source is infinite. In this slide, we can see how a voltage source is changed to a short circuit, and a current source is changed to an open circuit. In circuit analysis of superposition, it is always important to convert the circuit to the Thevenin equivalent. In doing this, we create a more simplistic circuit for us to solve for both independent sources. In this example, we see that we have two different types of sources, one being a voltage source of 36 volts and one being a current source of 9 amperes. We are asked to determine the current through the resistor 2, and in order to do this, we have to apply the superposition theorem to find the current running through the branch of I2. To determine the effect of the 36 voltage source in the circuit, the current source must first be replaced by an open circuit equivalent, as shown in Figure 3. This results in a simple series circuit with the current equal to I prime, which is also equal to E all over RT, which is also equal to E all over R1 plus R2. When substituting our values in, we get 36 volts over 18 ohms, which is all equal to 2 amperes. To determine the effect of the 9 ampere current source, this requires replacing the 36 voltage source by a short circuit equivalent, as shown in Figure 4. This results in a parallel combination of resistors R1 and R2. We apply the current divider rule to find I second prime, which is also equal to R1 times by I all over R1 plus R2. When substituting our values in, we get 12 ohms times by 9 amperes all over 12 ohms plus 6 ohms, which is all equal to 6 amperes. Seeing as both currents travel through the same direction in I2, we find that I2 is equal to I prime plus I second prime, which is also equal to 2 amperes plus 6 amperes, which is all up finding to be 8 amperes in total. This is an analysis of how superposition is applied to a simple circuit.